Hey, this is Mr. Ring going over the Chapter 2 test review for stats class. Question number 0. Can you predict the battery life of a tablet using the price? Using data from sample of 15 tablets, the least squares regression line, y hat equals 4.67 plus 0.0068x, was calculated using x equals price in dollars and y is the battery life. Interpret the slope. All right, so slope, let me zoom in here. Don't use a highlighter. Y hat equals a plus bx. Now, it doesn't matter which letters you use, a and b, they're interchangeable. But in this problem, the one in front of x is your slope. So slope is the change of y over the change of x. So the variables they tell you here are x is price in dollars. So for every $1, 0.0068 is the battery life, because y, the y variable, is battery life, bat life. So how do you interpret it? With each additional dollar, the predicted battery life increases by 0.0068. All right, let's move on to the next one. What does a y-intercept mean? A y-intercept on a graph, 0 and some kind of number. So when x is 0, y is a number. So we can say when price is equal to $0, what's the predicted battery life? The predicted battery life is 4.67 hours. Right? It's the number without x. That's what the y-intercept is. Okay, let's try the next one. What is standard deviations? What is the standard deviation of this model? So the standard deviation is the actual battery life is typically about 1.21 hours away from the number predicted by the least squares, regression line, right? If I have this line here, then the standard deviation of the residuals is either above or below. All right, what's the last one? What is r squared? R squared is the coefficient of determination. And so we can say in that sentence frame about what percent? 34.2. Remember, you just multiply that number by 100. And then I'll move it 2 decimal places there. Of the variability in the y, which is the battery life, is accounted for by the least squares regression line. Okay? So that's question 0. Let's go on to question number 1. The following segmented bar chart shows the relationship between gender and superpower. Preference for a sample of 200 children ages 9 to 17 from the UK. Is there an association between gender and superpower preferences? So again, these are called segmented bar charts, or you can call these stacked bar charts. And basically, if you think about it, you're taking a bar chart, that's a pie graph or circle graph, which is 100%, and then you're putting each of those pieces there, right? So that's why it has 100%. So can we say that there is an association? I want you to notice that this is categorical, and then this is numerical. So qualitative, quantitative. So we can say yes, there is an association. Why? Because there is a difference between male and female superpower preferences. We kind of talked about this way back in probably 2.1 or 2.2 that, invisibility looks the same, right? But if you compare the oranges here, the males prefer super strength, and then the females prefer, because that bar is bigger than this one here, they prefer more telepathy. And it looks like this one is bigger than, females prefer flying over males. Does that make sense? And then males prefer freeze time and over females because theirs is larger, the bar segmented part. Okay, question number 2. Identifying the explanatory and response variable. Remember my little trick? This one does the explains. So which one explains the other one? Well, the explanatory is the amount that you study. Explanatory is the time studying. Because the amount of time studying explains the response variable, which is your grade on the exam. Grade on the exam. Okay. Now you could argue the other way that the grade on the exam explains how much time you studied. That's kind of like the afterthought, but generally it's the amount of time studying explains what you will get on your test. All right, let's try question number 3. Describe the following scatter plot. Okay, so describe, we usually use the acronym SUDS. What does SUDS stand for? It stands for strength, unusual, direction, and shape. Or the S's can be interchanged. So what is our strength? They look pretty close to a line, so I would say strong. Is there anything unusual? Nothing unusual. How about the direction? Positive or negative? Positive. And the shape is what? Linear. All right, question number 4. Sarah's parents are concerned that she may be seem short for her age. The doctor has has the following record of Sarah's height. Make a scatter plot of these datas. So let's go ahead and put this into our calculator. Before I do that, I'm just going to do this. We can do the squiggly, and then we'll do 30. Count by, I don't know. That's too much because I got 60. So let's count by about tens. 10, 20, 30, 40, 50, 60. That's measured in months. And then height measured in centimeters for the Y. And then I notice 90, and then you can do your squiggly. Maybe you could do something like 80, 85, 90, 95. That's not high enough. 90, and let's just do that one, 100. And let's just graph it really quickly. You can use your calculator if you needed to. 36, 86, 48, 90, 51, 91, 90, 54, 93, 57, 94, and then 60, 95. Okay, so that's what mine looks like. Let's go to the next question. Sarah's parents are concerned that she seems short for her age. Their doctor has the following record of Sarah's height. Calculate the equation for the least squares regression line to predict the height from age. Okay, so let's just go ahead and put this into our calculators. Stat, edit, go up to list 1, press clear, enter. List 2, clear, enter. I'm going to go ahead and put this in, 36, 48, 51, 54, 57, and 60. And then I'm going to go ahead and press 86, 90, 91, 93, 94, and 95. Okay, if you wanted to graph this, again, you go to second, y equals, in the top left. Click on the first one there, make sure it says list 1, list 2, press done, and then you can just press graph. Uh-oh, what's in here? Oh, you press zoom, and you have those. That's cool. Didn't know that before. Okay, so there's my graph. It's hard to see, but those blue dots. Okay, so I'm going to press done. And now we want the least squares regression line. So you got to make sure your catalog is on. So second 0, go to D, diagnostic on. Press it. It's in the home screen. Press enter. Done. Okay, now stat, calc, lin reg. Remember, you can use either 5 or 9. It does not matter. Just remember which one's in front of x is slope, and one without x is the y-intercept. So now I'm going to tell where it is, and then this nice app tells me the formula I count to have. So x list 1, and then the y list. So that would be second 1, comma, over the 7, 2, and comma, frequency, just how often that number happens, so it's just once. And then where do I want it to store? I want to store in y1, so I'm going to press vars, y vars, and then I'm going to press y1. Okay, so here is my number. A in my equation will be the slope. B is the y-intercept. R squared is the coefficient of determination. Should we use that? Yes, it is very strong. And then R tells us the correlation or the strength and direction. So let me just write the equation. We have the predicted .383x. And if you wanted to, the predicted height is equal to x represents the age. So you can do something like that for question number 5. Try question number 6. Sarah's parents are concerned, blah, blah, blah. Use a regression line to predict Sarah's height at age 40 years old, which tells us, remember, age is x, so there's my x. And then convert your prediction to inches, and then using that. So they want to know what her height is. So I'm just going to use the equation we had. And then we said x was, we have to use this. Notice how this one's years and this one's months. That's why it gives us 480. So I'm putting that in for my x. Remember, I'm going to use PEMDAS, so I'm going to multiply first, then add 71.5. So my predicted is going to be 255.79 centimeters. It wanted it in inches. I'm just going to divide this number by 2.54. And this will give me inches. My predicted in inches is going to be 100.7 centimeters. Scrolling question number 7. I'm going to steal this because I'm going to use it again. Question number 7. Sarah's parents concerned that she seems too short. What is the residual at 48 months? So for residuals, we're first going to calculate the predicted, which basically says take x at 48 months. So I have 71.95 plus 3.83 times 48. Again, PEMDAS, we're going to multiply, and then we're going to add. My predicted is going to be 90.334. And then the next thing we're going to calculate is our residual. Remember, residual, we're taking statistics, but you want to take AP. So that's actual minus the predicted. So the predicted is 90.334. The actual is from here. So if you subtract those two, you get a negative. What does a residual of a negative mean? The actual is 0.334. What does the negative mean? Is less than the predicted height. Let me give you back a visual. So 4890 So you go back up to our graph, and 4890 should have been here. Oh, she's a different color. $48.90. That was her actual. But our predicted was actually here based on the line. So notice that our actual is lower. So that should give you a visual of how to do that problem. Okay, question number 8. Looks like the same question, but the bar chart has now changed. Is there an association? Well, if you just look at the size of, matching up the colors, yellow to yellow, fly to fly, telepathy to telepathy, they're the same. So we could say that no, there is no association this is the y part because, or they explain, because there is no difference in gender superpower preferences. What does that simply mean? One little segment is not bigger than the other one. Okay? All right, let's do number 9. The metabolic rate, the rate at which the body consumes energy, is important in studies of weight gain, dieting, and exercise. We have data on the lean body mass and resting metabolic rate for 12 women who are subjects in a study of dieting. Lean body mass, given in kilograms, is a person's weight leaving out all the fat. Metabolic rate is measured in calories burned per 24 hours. The scatter plot shows the relationship between metabolic rate and the lean body mass. And the correlation is 0.88. What would happen to the correlation if the metabolic rate was plotted on the horizontal and the lean body mass was plotted on the vertical? So basically, in this problem, they're telling us to switch the x and the y's. But if you remember back to information on our scatter plots, it does not matter because in correlation, the correlation would not change. So even if you did switch the x's and y's, like this goes here, and this one goes over here, you're switching the order pairs, but it would not change the correlation. Okay, so that's question number 9. Question number 10. What would happen to the correlation if the lean body mass was measured in pounds instead of kilograms? Would it change? Correlation. So this one's talking about unit change for correlation. Go back to your notes, you remember that correlation would not change. Would not change when units are changed. Okay, question number 11. Howard claims that correlation between metabolic rate and lean body mass is R equals 0.88 calories per a kilogram. Is this correct? The answer is no. Correlation can't have units. It's just a number between -1 and 1. It's just a number. There is no units, so that's wrong. Question number 12. Roller coasters with larger heights usually go faster than shorter ones. The equation of the regression line for this relationship is there. X is height, Y is max speed for 9 roller coasters opened in 2012. Calculate and interpret the residual for the Iron Shark, which has a max height of 100 and a top speed of 52 miles per hour. So they're telling us this information. So this is actual data. So if I just take the predicted and I'm first going to calculate the predicted. What would the calculated predicted for the Iron Shark be if X is height? So X is going to be 100. Multiply 0.2143 times 100 and add it to 28.17, you will get 49.6 is the predicted. Then we're going to calculate the residual. The residual is A minus P, actual minus the predicted. So the actual for the Y is 52 minus the predicted, which is 49.6. And this gives us 2.4. Whoa, that was ugly. (2.4). And this is my interpretation. What is 2.4? It's positive, so the actual speed is 2.4 units, miles per hour, faster, because this is positive, than the predicted speed. All right, question number 13. Roller coasters, blah, 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 same thing. Interpret the slope. Now, if you ever forget, again, I just think of the number in front of X is the slope. And remember, slope is the change of Y over the change of X. So if there it tells you X is height and Y is speed, and you have 0.2143, the question is, how do you make that a fraction? Well, you just put 1. So slope here is for every 1 additional foot, which is essentially your height, then remember this is a predicted, the predicted speed increases. Again, why does it increase? Is because this is a positive number by 0.2143 miles per hour. What does that basically mean? As the roller coaster gets taller, it goes faster. All right, question number 4. What does the y-intercept mean? And remember, this is the y-intercept because it has no number. So again, a y-intercept is when basically your x value is 0 and you have some kind of number. So we can say when the height of the roller coaster, remember x represents height, is 0, the max speed is 28.17. Now, you should now mention that if this makes sense or not. This doesn't make sense. Because roller coaster can't have height of 0. Can't have height of 0. All right. Still about roller coasters here. So question number 15. What would happen to the slope if the slowest and shortest, okay, slowest would be this one, and the shortest and slowest roller coaster was removed? So what would happen to that point? I think our data would become flatter. So I think the y-intercept would go up. And I think the slope would actually decrease near 0. So let's write that. Oh, this one just said slope. The slope would decrease because the line is less steep. So question number 16 says, okay, well, what happened to the y-intercept? We talked about that. So the y-intercept would increase. All right, question number 17. Calculate the correlation. All right, so I'm going to do the same thing here. I'm going to take these numbers and put into my graphing calculator. Stat, edit, enter, clear, enter. Put in these numbers: 10, 8, 13, 9, 11, 14, 6, 4, 12, 7, and 5. All right, let's get the numbers. What question are we on? All right, 8.04, 6.95, 758, 881, 833, 996, 724, 426, 1084, 482, and 568. Okay. Press stat, calc. len reg, I'm using number 5. And then I'm just going to repeat L1, comma, L2. 1 is for frequency, and where do I want to start? Store it, vars, y1. Okay, so here is my correlation now. So my correlation R is 0.816. 0.816. Now again, if you don't see it, make sure your diagnostic is on. Okay. Question number 18. What happens to the correlation if a point 2019-88 was removed? And you can just go to your calculator and then, if a point was added, so you can just add it to your list. Stat, edit. So 20 and then 19.88. Nope, that went on another list. Delete. Stat, calc, linreg, L1, comma, L2, comma, 1, comma, vars, y1. I just want to make sure, just in case we have to graph it later. Dimensions mismatch. Okay, if you ever see that, which I just told the student, stat, edit, I have, notice how list 1 is longer than list 2 right there, so I needed to click 19.88. Okay, stat, calc, linreg, L1, comma, L2, comma, 1, comma, vars, y1. And it still says that. What happened? I need to press enter. Okay, let's try that again. Stat. What am I doing? Cancel. Try that again. Stat, calc, linreg, L1, comma, L2, comma, 1, comma, vars, y1. That should get it. Okay, so my R value now is 0.897. And what did that do? R equals 0.897. It increased it. Right? That means it's closer to that line that we were predicting. Okay, we got some graphs here. What can we do with these graphs? Here's the data collected on 12 brands of movie candy. Scatter plot shows the relationship between X amount of sugar and the number of calories along with the least squares regression line. The standard deviation of the residuals for this model is S equals 105.5. Interpret this value. Okay, so remember this, the red is the predicted, but the actual is this candy is like super sugary, right? Maybe it's like a Sour Patch Kid, or maybe like this one's below, so maybe that's like a healthier candy that has less sugar or number of calories in it. So, so those are examples 1 above and below. So the actual number of calories is typically about 105 above or below the predicted least squares regression line, right? All right. So same thing, but they want to know what R squared is. R squared is the coefficient of determination. And we have that sentence right. Blank of the variability in the Y is accounted for by the least squares regression line. So again, you're taking this number and you're multiplying it by 100 to get a percent. That's a percent. So 38.2% of the variability in the, what is the y, which is in calories, is accounted for by the least squares regression line. Okay, number 21. Long-term records for the Serengeti National Park in Tanzania showing interesting ecological relationships. When wildebeest are more abundant, they graze the grass more heavily, so there are fewer fires. Researchers collect data on one part of the cycle and compute a least squares regression line relating y, the percent of grass burned, to the wildebeest abundance in thousands of animals in the same year. Here's the residual plot of the data. Use the residual plot to determine whether regression is appropriate. Okay, so remember, the red line is 0, which means it's exactly on. These are actually above, and these are below. So if you had, you don't need to, but I'm just kind of help you understand. Okay, this was the least squares regression line, right? The yellow I just did is like above, and the green is below, right? The data is there. So in residual plots, we want to figure out, is it scattered? That's the question. And if it's scattered, then it is good. That means that we should use a linear. Let's write that. Linear regression model is appropriate because the residual plot is scattered with no pattern. Okay, so if you see a pattern there, then that's bad for linear, and we have to use a different model like quadratics. Okay, same thing, but now we have to explain the standard deviation. The actual percent of grass area burned is, remember in statistics we can't say absolutely, so this is a good word to use, is typically about 15.99% away, so above or below, from the number predicted by the least squares regression line. Okay? All right, let's try question number 23. Same thing, now they want us to know about R squared. Okay, so remember the coefficient of determination, the R squared, if it's a high number, then it's helping us determine if I should use it. But for right now, I'm just going to interpret, and then I want to give you guys a real quick review about correlation. About 64.6% of the variability in the percent of the grass area burned is accounted for by the least squares regression line. Okay, so we didn't do a scatter plot, but that's not a high number. Would I still use it? Yeah. Could I run a quadratic or exponential and my r squared value is higher? Yeah, that might be better. Remember, if you ever have to find the r value, you just take the square root and you'll get some kind of number. Does that make sense? So if you ever had to find correlation r, you just take the square root of that. Okay, M&Ms. Student opened a bag of M&M chocolate candies, dumped them out, and ate all the ones with the M on top, meaning it was showing up. When he finished, he put the remaining 30 M&Ms back and repeated the same process over and over again until all the M&Ms were gone. Here are the data of the number of M&Ms remaining at the end of each of the first 6 courses. Calculate a model for these data using the course as the explanatory. So this is your X and this is your Y. It's telling me exponential. So let's go ahead and put that number in. Stat, edit, go to L1, clear, L2, clear, and then go to L1. So I have 1, 2, try that again. 1, 2, 3, 4, 5, and 6. And then how many M&Ms were remaining? 30, 13, 10, 3, 2, and 1. Okay, so if you ever wanted a graph, you could just press graph, and then I didn't know this, bottom left zoom, and then zoom stat. So then we should see those numbers. Now, forget the green line. The green line is actually from our previous problem where I asked you to store it. Does that make sense? So the blue is my blah, 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 my exponential. Okay, so let's get an equation for the exponential. And I should have just made the, let's press clear. So stat, calculate, and then A, so exponential model regression. L1, comma, L2, comma, 1, comma, vars, y vars, y1. Okay, there's my equation. So A is your y-intercept, B is your common ratio, r squared, coefficient of determination, and r is correlation. So I know it's going to be a negative and a strong. And then if we went back to our graph, it should be there. There it is. See it? Okay, so let's write that equation here. So my answer is, my predicted is, remember that's in the form of ABX, so 57.93, B value 0.506, and then remember this X has to be small because it's exponential. That's my answer. Okay. Calculate and interpret these residuals for this course. Okay. For the first 6 courses. Then it tells us to, here, let me highlight this part. Calculate the residual for the first course. Okay, so I'm going to take the equation from above. Y hat equals 57.93, 0.506, and then X. Okay, X, first course means this. So they want an X value that is 1. X value that's 1. So that is 1. Teach you guys a calculator trick. So press done. And then let's just go to table. And you can just press 1. And you get an answer. 29, if you round up, 32. My number's off by a little bit. What's wrong? 57.93.5006x. Let's make sure that is in my graphing calculator. Y equals 57. Okay, so I know why. It's a rounding error, but that's okay. So if you actually did just, my numbers were slightly off, and it's because I was rounding. So if you don't round and you use the numbers here in the blue screen, you will get my predicted to be 29.31. So again, this is my predicted. And then the residual is actual minus the predicted. So the actual is 30, and the predicted is 29.31. So if you subtract those, you get approximately 0.687. That means the actual, this is my interpretation, the actual number of remaining is 0.687 more, because this is positive, than the predicted. Right, the equation we have from our data is making a prediction, and you look compared to the actuals, and this one is the actual is higher. Question number 26. Okay, team of researchers measured the carapace, which is the shell length. I had to look this up. I don't know. That's my turtle. Okay. And the clutch size, which is the number of eggs for the female gopher tortoises in Ocklawaha County Park, Florida. I don't know what that is. Here is the data for the 16 tortoises. Calculate the quadratic model for the data using the carapace length. I guess they didn't really give us 16, right? Maybe we just have 8. So let's put those numbers in. Let's put in these numbers. Let's see. So I'm going to put these in my calculator, stat, edit, clear that, clear this one, and then I'm just going to put these numbers. 284, 290, 290, 298, 299, 302, 307, and 309. And I'm going to go ahead and put in the clutch size, which is the number of eggs. 3, 2, 7, 11, 12, 10, and 8, and 9. Okay, so then let's just go ahead and go second mode to quit. Stat, calc, and then quadratic regression, which is number 6. L1, comma, L2, comma, 1, comma, vars, y1, just in case I want to see a graph. And then I have it right there. So that is my, I'm just going to put in all of those numbers. And if you look at the coefficient of determination, probably not too strong, but it's what we got, because that's what the problem told us to do. Make sure my numbers match up. Yes. Okay. So let's put those numbers. This is standard form for quadratics, and then we'll just put in those numbers. Negative, which means it's going upside down graph. And our C value. So that's my answer for number 26. Number 27. I think it just meant 8 tortoises. Interpret the residual for the tortoise with a carapace for 298. So that would be this one. So this is my X value is 28, and then we'll subtract that by 11. So just use my calculator so this goes faster. So if I put in X equals, 298 here, I'm just going to use my calculator, table. And I have the second table set, and it says I have ask highlighted. So it's asking me what number I want. So I'm going to go to table, and then here I just want 298. And it gives me an answer of, it's not good. Let's see. Table 9.76. That number is off. So let's just go with our number, 9.76. Okay, so again, if you put in there, just change colors, negative 0.290, square that number first. So again, I would do PEMDAS, which means I would exponent, then multiply that number and subtract. So you would get, what did we say, 9.76. That's my predicted. So this was to predict. And to get my residuals, actual minus the predicted, my actual for that problem is 11. So 11 minus predicted, which is 9.76. I'm going to get 11 minus 9.76 gives me 1.24. The actual clutch size, double check all my numbers really quickly. $284, $290, $290, $298, $299, $302, $307, $309. 3, 2, 7, 11, 12, 10, 8, and 9. Well, that's what I got. So clutch size is 1.24, greater than the predicted. So my line is going to predict that equation in yellow there is going to predict, based on the size of that tortoise, 298, they're going to predict a 9.76, so the actual is 11. So we need a higher one. Okay. Let's do question number 29. Did I skip one? Did I get 28? Ah, 28's over here. I knew it. Okay, for number 28, it's saying compute the least squares regression line for predicting y from x given the summary statistics. So you have the mean or the average. Let's just write that. Whoa. Where am I at? You have the mean or the average of x. That's the standard deviation of x. You have the y mean or average. You have the standard deviation for y, that one's x, and you have the correlation. So these are called summary statistics. Let's highlight that. And there's a couple of formulas that you should have. I'm going to pull out, if you haven't created one, create a formula sheet. Just go back and look at all of the you can have one. That's what we would use in class. So I'm just going to use this one. and the y-intercept is a minus y bar minus b x bar. Oops, that's the wrong one. And the slope is r, the correlation, times the standard deviation of y over standard deviation of x. Okay? All right, so let's go ahead and compute this one. Okay, so A equals y bar, which is 1350, minus the b value. Okay, what is the b value? Well, it's up here, so I need to calculate slope first. So my r value, which is 0.7, times standard deviation of y, which is 101, over standard deviation of x, which is 3. Okay? And if you put that in your calculator, you will get 23.56. That's repeating. It's okay. So I'm going to put that value here. So let's move this part. So we said that number goes there. 23.56 times x bar, which is 6. So now I've used all of them. So when you multiply that, you get 1208.6. Okay? And then you just put it back together. So what color haven't I not used? So that would just basically be y hat equals, in this case, this is my y-intercept, and the b value is my slope. Okay? So that is my equation. Okay, and then the last one, if you guys put those numbers into your list, question number 29. Okay, remember this is your x, y, x, y, x, and y. You're going to have to run your one var stats. So put it into your list, then stat, calc, and then one var stats for each of the list. Let's do that. Sorry, magnifying my numbers so I can actually see them. Clear. Okay, 86, 62, 52, 90, 66, 80, 78, 74, 58, 64, 74, 76, 56, 72, 72, 68, 60, 80, 66, 80, 78, 74, 90, and 76. It's a good strategy that I just did is like actually saying them out loud. And if you have someone else there just doing the video, then you just input the numbers. 70. So now I'm doing the afters. 110, 76, 96, 86, 84, 128, 74, 106, 84, 96, 82, 78, 90, 70, 92, 70, 92, 116, 114, 116, and 94. Okay, so I'm going to calculate one of our stats for each of those. So stat calc, one of our stats. And then here, you just need to put in your list, second L1. Okay, and there's my summary statistics that I need. I need X bar and SX, which is standard deviation. Okay, and then if you did stat calc, one var stats L2, you need, this is essentially a Y bar and SY, or standard deviation of the Y list, which is SX. And then to get your correlation value, just do stat calc lin reg L1 L2. And then there is your R value. Okay, so let's go ahead and copy those down. So we had 72,166. I'm not writing here. Where am I writing? 72.1667. That's a 6. And then 10.21366. 90.75. Standard deviation of the Y 17.78922. And correlation 0.848649. And then you just repeat what we did in the previous problem. I'm just going to give you the answer for this one. Y hat. You're just using your summary statistics. Again, look at question number 28. And you should get an equation that looks something like that. Remember, you can always change the y-intercept order, so 29.6018 plus 8473x. But you're meant to plug and chug using these formulas from question number 28. Okay? So I hope that Chapter 2 test review was helpful for you guys. See you.